Welcome to this Techtrain session. Tonight we're going to take a look at extending Azure management to any infrastructure with Azure Arc. Now, first of all, who am I? My name is Geert Bake. I'm doing Microsoft incubation at Kronos, but I'm also a cloud native architect and technical lead for our customers. And of course, you can follow me on these channels. This session is actually part of Techtrain, which is a monthly event that is done by the Kronos Group, but open to anyone, where we focus on aspects of the Microsoft Cloud. So today this is going to be a more Azure focused session. Next month we are planning a session around the Power Platform. So you'll get the invitation to that as soon as possible. Now, what are we going to do today? Of course, Azure Arc, as we said. And of course, customers today, they're moving to the cloud faster and faster. But that means that you still have many different types of resources in other locations as well. Not everything is in one cloud. You might have multiple clouds. You have your private clouds, or let's say your on-premises data centers, because they might not all be a private cloud in the true sense of the word. And of course, you have your edge environments like your warehouses, factory floors, and maybe even oil ramps and so forth. Now, the Azure Arc is part of Microsoft's hybrid strategy, and there are a couple of aspects to this. And the first aspect is what you already have today. So virtual machines, servers, physical machines, it doesn't really matter. But also Kubernetes, which is more and more becoming a standard of deploying applications everywhere. You might want to bring those under control in a consistent way using the Azure portal and Azure Resource Manager. So you take what you have and you bring it over, you project it into the Azure control plane. That's one aspect of the Azure Arc puzzle, so to speak, or one piece of the puzzle. Now there's another aspect as well. There are specific Azure services that you might want to bring to on-premises or to the edge for latency or other kinds of reasons. You might want to have Azure databases that you already know and use, like Azure SQL or Azure Postgres, and you'd like to bring them to, let's say, your factory floor or to your on-prem data center, but they are managed the way Azure manages databases. Well, that's possible. That's the data piece, so to speak, of Azure Arc. It is important to know that that requires Kubernetes at that location. So if you want to, for example, deploy Azure Postgres, the database, to your on-premises environment, you can do so, but you would do that on Kubernetes. Now, this is a part of the puzzle we are not focusing on today in this session. So let's take a broader look, but first start with Azure Arc for servers, or basically the Azure Arc enabled infrastructure. The left part we're going to start with, which is the Azure Arc enabled servers. And it's important to note that that part is today generally available. So you can use that in production. We'll also take a look at the most right piece of the puzzle, which is Azure Arc enabled Kubernetes. But bear in mind that this is public preview. There are also some private preview bits because they're working quite hard on this offering. It's not really recommended today to put that in production. There's actually another piece of the puzzle about already existing SQL servers. You can also Azure Arc enable. Yeah. This is not a SQL server you install an Azure kind of SQL server, but already existing SQL servers running on normal infrastructure that you also want to view in the Azure portal. We won't focus on that one today. So just the left and the right part is what we are going to look at. Now, the question you might ask is, why would you want to do this? We have, of course, several customers who are doing a migration to the Azure cloud. And then all of a sudden, of course, you are confronted with the fact that there are certain systems that might not be so easily moved to the cloud, or that have to stay on premises or at the edge
for a longer time. And then you have this, this inconsistent governance across cloud and on-premises. And of course, when you start moving servers to the Azure cloud, you have nice pieces such as Azure Policy and other components that you might want to use also on your on-premises servers. And that's what, of course, Azure Arc enables you to do. When you also have your server split or Kubernetes cluster split between these environments, you might also have an incomplete view, an incomplete inventory of all your systems. Of course, if you bring everything over to Azure ARM, to Azure Resource Manager, you of course can use things like the resource graph and so on to start querying all these systems, maybe based on tags you have added to those systems and so forth. So you have a complete inventory of all the systems. And there's always this thing as well with customers that they desire a single pane of glass approach, and that's for sure possible from the Azure portal. And when we think of the SQL and Postgres pieces that we can deploy on Kubernetes clusters, on premises, you might want to do this for edge and low latency use cases where you cannot really use the cloud-based offering there. And for some, it's decommissioning older management tooling, depending, of course, on how old the tools are and how useful they still are. They might want to start using cloud-based tools here as well. But for most of the customers, they have this thing like, this inconsistent governance across the platforms, and this incomplete view is something that Azure Arc can solve for them, right? Now, in this session again, we're focusing on servers and Kubernetes, and let's start with the server part. The server part is if you look at the slide over here, it's first of all you have to reach as much as possible all kinds of servers you have in your estate. So in this case, for example, Linux and Windows is supported. Doesn't matter if it's VMs or bare metal, of course. And it's also fully domain agnostic. So there's no need for your Windows servers, for example, to be part of a domain or a specific domain. It doesn't really matter. Once you put the agent on the server, it will report its inventory to the Azure portal, and you will see it there. From the moment you have done that and the server is in the Azure portal, you can, of course, have it completely inventorized, do queries on them and so forth. And you get this consistent experience that's consistent with Azure VMs that you deploy natively in the cloud, including the VM extensions. And so for those, for example, who have worked with Azure VMs, native ones, you have this extension experience to easily enable other features in your VMs that is carried over to Azure Arc as well. So that's something we'll see in a moment. Now, from the moment you have these systems all in Azure Arc, you can use Azure Policy with it. And so we go to the governance and security aspects, where you can set your security baselines and also start checking them on your on-premises systems. So basically, you want to have this virtual machine experience you get natively in the Azure cloud. You want to have this on your on-premises resources as well. Now, it's important to note that when you enable a server via Azure Arc, there are basically two pieces, right? So when you enable a server, you just connect it up. That's the agent part. You drop an agent on that server, and then you select the additional services you want to add to that server. So if you just want the inventory, you just want these servers to show up in the portal, but don't do things like patch management or monitoring these systems, that's entirely up to you. If you want to indeed use these additional Azure services like Azure Monitor, that you have to enable as a separate step. And that's supported across Windows and Linux systems. Now, I must warn you, you might have some trouble here and there with different Linux flavors. So in our experience, for example, when you enable things such as Azure Monitor and the dependency agent on CentOS image, if it's the correct version, works perfectly well. On some versions of Ubuntu, you might have some issues with the dependency agent. So it depends a little bit on the flavor, if it's going to work well or not. And always check the documentation there, because there's a list of supported Linux operating systems and versions as well. And that's, of course, when you work with a different one, you might see that those additional pieces might not work as you expect. But typically, just Arc enabling the server, dropping the agent there, that's usually not an issue. Now, what I wanted to certainly call out already in advance before I go to the demo is that it is now possible to also use managed identities with these Arc-enabled servers. So for those who have worked with Azure, native Azure VMs, for example, or other services in Azure, you probably know about the concept of managed identities, where, for example, a software developer can just reach out to a certain endpoint to request a token to do something, for example, against Key Vault, right? And then you don't have to do or save credentials in the VM that you're working with. And this is carried over to your on-premises systems now. So whenever you Arc enable a server, wherever it is located in the world, it will have its own managed identity. And if you're running software on that server, it can use the endpoint, an endpoint, specific endpoint on that machine to request tokens to do other things in the Azure cloud based on that identity. That's quite a powerful concept that you can carry that over to any server you want, and that's supported for Linux VMs anywhere or Windows VMs anywhere. It doesn't really matter. Now, instead of just talking about that, let's just take a look at how this works. So we'll go to the Azure portal here, and I'll show that on the screen. One moment. And of course, if you look at how this works, there's this Azure Arc section in the portal, where of course all the pieces are part of this. And so what you'll see here is that you have both the infrastructure pieces and the data services pieces. As I said, we won't look at this. This is what you deploy on Kubernetes, but we will look at the servers and the Kubernetes aspect here. And of course, for servers, you can just click over here and you can see all the servers which are Azure Arc connected. In my example, this is my own subscription. I have a Linux and a Windows VM here. Now, maybe first the experience on how you add these servers. You either do this interactively or you do it at scale with a service principal. So if you're doing it, for example, interactively, you will have to authenticate yourself while you're installing the script on the server. You will have to authenticate to Azure to basically hook up the server to the Azure backplane, so to speak. If you don't want to do that interactively, you can of course create a service principal, and then with that service principal and a script, deploy that using any deployment mechanism that you want to use. I'll just use the interactive script here just to show you what's going on. So if I'm actually going to the resource details, you'll of course will see that you will need to provide a resource group, because what you actually are doing here is you are creating an object in Azure Resource Manager. This Azure Arc enabled server is an ARM object, and an ARM object always has to be in a resource group. So that's where you have to put them. And of course, you select where you want to do that. And you should also select the region, of course, as closely as possible to where your actual resources are, because your VMs will connect to an endpoint within that region and send their heartbeats to it. They send regular heartbeats to show that they are still alive and still actively connected. I'll use Windows now, but for both Windows and Linux, you can also set a proxy server URL if that's something that you need in that location where the system is running. Now, just like any other Azure resource, you can do tagging, but in this case, because Azure Arc knows these will be systems outside of Azure, some physical location tags are proposed already. So data center, the city, the location, and so on. You can add them yourself and also add custom tags. That's just like any other Azure resource, so that's not that special. And then you have the following script you have to run. Now, this is Windows, so I think it is quite clear. You download an MSI here. The MSI is then installed with MSI exec. And then part of that installation, you get the AZ-CM agent. And the AZ-CM agent with the connect option, that one will basically do the link up with the Azure backplane, so to speak. And at that point in time, because this is interactive, you will also be asked to authenticate and to create basically that object in the Azure environment. Now, if you're going to a machine that has this that has this running, you'll see that here this is a VM actually running on my own system here. If we're going to program files and we're going after that to the Azure Connected Machine agent, you will actually see there that the AZCM agent is running over there. So you can always run that on your machine, then maybe use the show command with the --JSON. That makes it a bit more machine readable friendly, so to speak. And there you can now see on the machine itself, yeah, the machine is connected, fine. It sends its heartbeats, and so the last heartbeat is sent, and logging can be also found in this HIMDS.log in case you want to troubleshoot these things locally. So this means that this VM is now running perfectly and is connected to the Azure Resource Manager. Maybe just quickly, if I'm going to my Windows folder here in System32, I also have a script. I will just cat this out. That is msi.ps1. It's a PowerShell script. And this is actually using the managed identity. We won't go into too many details here, but basically this script is asking for a token to do things against the management.azure.com, so against the Azure Resource Manager. So if I run this script, for instance, you will see that it actually connects to this metadata service, which is now running on this machine, just like it's running on an Azure VM, but it's now running on a VM here at home where I'm doing my presentation. And when I'm actually executing this, is getting now a token that I can use to talk to the Azure Resource Manager, for example, to create resource groups or create a new VM or do whatever I want, that the managed identity of this VM has access to. And of course, this managed identity can be found when you're giving access right, for instance, and I'm going to my subscriptions, for example, and I'm clicking on my subscription and I'm giving access control here. I can just add via a role assignment, and I can just look for my machine, which is called win. And then you'll find a bit further, you'll actually see this one here. This is the managed identity for the VM that I here have running at home, but that has Azure Arc installed. So if this has all the access right that I need, I can just with that token do what I need to do. So that's great for developers or for certain pieces of code you want to run on your virtual machine, that you have access to managed identities as well via this system. Now, if you go to the actual servers that I have running on my system here, so I had two. I had my Windows system and I had my CentOS system. I'll just click on the Windows one. This is what you'll see for an Arc-enabled server. So very similar to the view that you normally have of a regular VM in Azure. You can see indeed your computer name, the operating system, and so forth. But it's clearly an Azure Arc VM because it doesn't show everything at the left side here. And you can also clearly see that it's a Azure Arc server over there. I have my tags here as well, so anything that I want to do is possible. Now, this what I'm saying is when you're connecting up the server, that's just a connecting piece. You have the inventory and you have this view in the portal. But then, of course, you can start adding this additional functionality. For example, if I want to do my monitoring as well from or via Azure, I can install all the necessary monitoring agents, etc., on the system. So, for example, what you see here is a result of the dependency agent that's installed on the machine here at home, seeing all the connections going out and etc. I can click further on these links and see the traffic for this specific connection and so forth. That's a dependency agent, but I also have normal performance graphs here. Basically, this is again what you have today with what is possible on a native Azure VM in the Azure cloud. I can carry that over to any VM that I have running anywhere if I just enable the insights piece of the Azure Arc server. Now you should be aware that this is actually enabled via extensions. So when you enable insights, there are extensions being dropped on the machine. And here you can see indeed the dependency agent and the Microsoft monitoring agent, which is forwarding all the information to Log Analytics, of course. Log Analytics is behind all of this, these visualizations and these insights. But of course, you decide if you want this or not, because you might use other tooling for this for on-premises. So it's a decision that you always have to make there. The same for the other pieces. For example, if you want to do your update management via Azure, you could do so by just enabling that for this VM. So I can clearly see that I'm missing a few updates on my local VM here at home, and also the inventory pieces and the change tracking pieces are working as well, right? So that's what Azure Arc provides on top of the connectivity, these additional features. And I shouldn't forget, of course, the integration with Security Center and Azure Defender for servers, because that's also active for my on-premises servers now. So I get a couple of recommendations here, what I should do on my system. And by the way, he would also do this for potential security incidents. If I go to my CentOS VM, you'll see that he's actually seeing, well, he's checking for that failed SSH brute force attack. So indeed, this VM is running somewhere, I think, in Germany in some kind of cloud. And yeah, he's seeing that there are suspicious things happening towards that VM. That's part of the Defender piece that's also active for these systems. And so quite a lot is possible. And on top of all that, we have, of course, our Azure policies. So Azure policies, if you use that in Azure already for your VMs, that's perfectly possible to use that in your on-premises VMs as well. If I show this for Windows, I just enabled one that is clearly not compliant because I couldn't really demo that in real time because it takes too long for these things to be evaluated. It takes several minutes that you would have to wait. But for example, here, I set a policy that verifies, is the domain member or is the server member of a certain domain, baka.info? And if not, then it's not compliant. So he's clearly doing that. He's evaluating domain membership. And I can see this is just a workgroup system, not a domain join system. And that's just made viewable within the Azure policy pieces that Azure provides. So again, all working against my on-premises VM that's outside of Azure. So very similar experience to what you have with VMs that are running inside Azure, right? So that's something, the server piece, that's basically what it looks like today. And again, important to note, this is generally available. So this is something that you can use in production and what customers are already using today in production to manage some of their VMs in their environment. Yeah. Now that's the server piece. Now, of course, the feedback that was received is that many customers are also having more and more Kubernetes environments on different locations. For example, I talked to a customer, I think last week it was, that was thinking about deploying Kubernetes at several edge locations because they wanted to standardize the way how they package and deploy their software. Their standard was more and more becoming just Kubernetes. We don't want to use VMs for that or other systems. Kubernetes is our standard. Yeah, of course, if that's the case, then you're going to deploy Kubernetes on many different locations. You might also want to have a system to manage all of these systems from one place. And that's what Azure Arc enabled Kubernetes is doing here. So just doing servers was clearly not enough. So servers and Kubernetes, that basically has the whole spectrum virtually covered actually. So there we also have a couple of pieces. We have to connect up these clusters. And in this case, again, virtually any cluster can be connected. There are a couple of verified ones and tested ones. They're in the documentation. But if you try to do this on any standard distribution of Kubernetes, it should normally work, right? That's the connecting part. Now, an important aspect here is that they added a software delivery part to Kubernetes. Probably have seen this with the servers. There's not something where I can say I'm gonna push software to my servers. That's not in there. In the Kubernetes part, they do enable this. So they provide you with a way to deploy software to your Kubernetes clusters out there in the field using a GitOps workflow. And I'll come back to that in a moment. Yeah, Vincent is saying Flux v2. Yeah, it's still Flux v1, but I'll come to that. Now that's the configure part, and of course, after it's configured, we need to again have the ability to monitor our Kubernetes clusters. We'll use Azure Monitor integration for that. And then again, the Azure policy piece is also available for Kubernetes clusters, where it's a bit more complicated because, of course, we're talking gatekeeper here and other kinds of systems, and that makes it a little bit more complicated than standard policy on servers. Now let's check out the connect piece first. The connect piece is basically very easy to do. I'm not going to demonstrate that because it's fairly simple. But what you have to think about is you just need to have your cluster connected with the kubectl command. If you're connected to your cluster with that command, just make sure you have Helm installed. And then documentation will make this clear. You need to install several extensions to the Azure CLI, right? And that's, of course, to enable this command over here, AZ connected Kubernetes connect. That's not standard, a part of the standard Azure CLI. You have to install extensions for that. Again, note these things are beta and they are in public preview, so good for testing, not for production. And just like with servers, you will have to provide a resource group because you're creating an ARM object of a specific name in the Azure ARM system here. Now, these commands, they will use Helm v3, so you have to also install that on your local client machine because a couple of Helm charts will be deployed as part of running this command over here. Now, what do the Helm charts do? The Helm charts actually deploy the agent pieces and other management pieces to connect the cluster to Azure Arc as deployments, as pods on your cluster in a namespace called Azure Arc. So once you run the connected Kubernetes connect command, you will see these extra pieces appearing on your cluster. When they're running fine, they will again report the cluster to Azure, to the Azure backplane. We'll do also a heartbeat once in a while and listen for further instructions to know what to do for the other scenarios. What will you see in your Azure portal? Again, a representation of, in this case, not a server, but a Kubernetes cluster. If you've worked with AKS, you clearly see that there's again a difference. There's much less to see here at the left side. Probably more will appear over time, but I can clearly see this is a cluster, a remote one running 1.19.3. By the way, this one is a cluster running at DigitalOcean, so that's another cloud vendor. But I'm doing the management from within the Azure environment because DigitalOcean does not have these fancy pieces to manage your cluster. So that's basically when you run the connected Kubernetes command, you basically just get this. And then just like with servers, there are added pieces that you just enable or not, depending on what you want to do. Now, for a lot of people, the configuration aspect is quite an interesting one, because that one is using a GitOps workflow to basically deploy extra software and components to these connected clusters out there in the field. Now, the important thing here is that this system, this GitOps system, is using a pull mechanism. So when you have your clusters deployed in these edge locations, for instance, it wouldn't be very practical to try to push your software to all these systems, because you would have to be able to connect to all the API server endpoints of all these Kubernetes clusters. Depending on your network topology, that might not be so simple. So it's actually more interesting to have something listening inside your cluster and check an external system to see what it has to do. And that's basically what GitOps does here. So we will basically use Git as the source of truth for the system. There we add all our changes, and we can see in Git what has been done. Now, what will we put in Git? We will put the Kubernetes system state that we want. We describe this, yes, we know this, typically in YAML files, or we use Helm charts for this and so forth. And this is all put in source control. From the moment that the changes are approved, via pull request, for instance, we have this agent running in the cluster that will enforce the desired state that's inside the Git repo. So we have two things that we have to do. First of all, we need to have an agent deployed to the cluster. And secondly, we need to have a Git repo where we describe our desired state. Now, Microsoft could have said, well, we're gonna create our own system here to do GitOps. Other cloud vendors have done that, but they chose not to, which is actually a good thing. They chose to work together with a company called Weaveworks, and they've created a tool called Flux. And Azure Arc is using Flux as the GitOps operator of choice. Now, the current version, Vincent, it's Flux V1. Last time I checked, it was version 1.20. But I talked to the Azure Arc team a while ago during a meeting, and they're actively in talks with Weaveworks to see how Flux V2 can be supported in the future. Flux V2 has many additional benefits like easier dependency management and so forth, which would be very beneficial for GitOps carried further in your daily workflow. So that's certainly a good thing that Flux V2 is coming. But for now, it's Flux V1. So if you're learning about how do I do this GitOps thing with Flux, and you're searching on the internet, search for the Flux V1 documentation, because that's how Azure Arc does it today. Now, how does that basically work? It's actually not that complicated if you look at it. So you have your Kubernetes clusters, can be any Kubernetes cluster, as I said. And now I've already shown you how you connect it with that AZ connected Kubernetes command. Now, that does not install the Flux operator. So that doesn't install the GitOps pieces. The GitOps pieces are installed in a separate step by creating a GitOps configuration. And from the moment you create a GitOps configuration in the portal or with the command line tools, the agent will notice that. We'll see, hey, there's a GitOps configuration for me to configure. Great, let's do that. Flux will then be deployed. So this Flux tool, Flux V1 that I talked about, will then be automatically deployed by the GitOps configuration. There's no need for you to know how to install Flux and where to get it and put it on your cluster and so forth. That's Microsoft is doing that for you and making it easy to do from the Azure Arc Kubernetes pieces. Of course, part of the GitOps configuration, there will be a link to a Git repo, right? So once Flux is linked to that Git repo, it will read the Git repo and start deploying here in step 5. Start deploying everything what was defined in the Git repo. All the YAML files and other things that you put in there will be deployed to the cluster. When an operator then makes a change and does a Git merge, Flux will notice that, and Flux will then say, well, okay, a new version, V2 will be deployed. Now notice, and that's very important, Flux by default is checking based on a schedule. So if I'm saying check every minute, it will go every minute to your Git repo and apply it, which also means that if you make manual changes to your cluster, which you shouldn't do, by the way, but if you were to do it, they will be overwritten every minute by what Flux is doing, if there are conflicts, of course, in what you do, right? So that's basically how it works. And now you'll see how to enable it and how easy it actually is to enable that on a Kubernetes cluster. So if I'm going to Kubernetes, in this case, they are all shown together in a list. If I'm selecting Kubernetes services, this is a normal Azure cluster. This is the DigitalOcean cluster connected via Azure Arc. What you'll see here is, and they recently changed this, by the way, they made it into GitOps now. So if you click on that, you'll see here the list of configurations. Now, to make it easy, I already created a configuration here and added it by just using the plus here and then add configuration. And here you would provide all the parameters that you need to deploy Flux and to point it to a Git repo. If I click on the existing one that I made already, you'll see the following thing, that I actually said, okay, you install Flux, give it some kind of a name here, CC I called it, that's just a choice that I made. And of course, we need to connect it up to a Git repo. Now, today, you cannot use HTTPS and so on as links. You have to use the Git link or the SSH link. So typically, I use this, the Git link, as you see over here, and that is actually going to this repository here. This is a Arc demo repository on GitHub, but you can see it is private, so it's not a public repo. So of course, I will have to do something to make sure that Flux, in this case, can read from this Git repo. Now again, Microsoft makes this very easy, I must say. Normally you use the fluxctl command to retrieve the key that was used and so on. No, what they're doing here is, when the operator state is installed and everything went perfectly, you actually get here the SSH key that you can copy and paste, yeah, and that you can actually put here as a deploy key in GitHub. I did that already, of course, before, but that's just here in this part, deploy key. You would add a new deploy key and paste that key in here. That's something you have to do because, of course, Flux needs to be able to authenticate to this private repo, in this case, to be able to view the actual code that I put in a folder called app. And there you see all kinds of YAML files that contain stuff to be deployed. And that's not really important what we deploy here. Now, of course, Flux is an operator, which in this case can be configured with additional configuration. Yeah, these days, your branch is typically main instead of master. Well, I will have to tell Flux, hey, the Git branch is main, because it doesn't default to that today. Well, in V1, it doesn't. Yeah. So this is actually all which is required. Now, what does this do? From the moment I create this configuration, what actually happens on my cluster? Well, what happens on my cluster is this. If I choose or show the view, I'll go out of this because this you don't need. Here you see that indeed, I called it CC, right? Namespace CC, and then the operator is also called CC. This is actually the Flux operator, which is running here, but Microsoft did that for you. And this is just a dependency that Flux uses. That's memcached. That's not so important, right? So all these pieces were installed automatically by Microsoft. And what you see here in the default namespace is what was deployed to my cluster. Now, of course, what I'm seeing here, I'm seeing 3 instances of Redis app here. If I want to change that, I can just go to my Git repo, change it, and then Flux will pick it up and make it, for example, into 1 instance. So that's how you would do this, this management. So it's great that you have these kind of GitOps configurations for your Azure Arc clusters. And a small voice in my head is actually telling me that this might come to normal AKS clusters as well, but you didn't hear that from me. Stay tuned for that, I would say. Good, that's the GitOps piece. And that's, of course, a very powerful thing, because that means that if you have multiple clusters out there in the field, if you all point them to the same repository, you can all modify them at once from that same repository. So really, a really important piece and an interesting piece on how to do your multi-cluster management there, right? Good. There's a few pieces left. where we're going to go a bit quicker over. That is, now you have connected and configured your cluster. Yeah, you want to operate and monitor the cluster as well. And that's, of course, Azure Monitor for containers. If you have worked with AKS already in Azure, well, there you have built-in monitoring capability using Azure Monitor. And that's enabled from the Insights tab. For a Kubernetes cluster, which is Arc enabled, it's actually the same thing. You can see it here, still preview though. Of course, to enable it, you have to run some commands. So you will have to deploy some Helm charts and so on that cluster to link it up to Azure Monitor in the cloud. So it's a different onboarding experience, but the end result with the Arc enabled cluster is the same. You have full visibility into what happens into your cluster. That also means that you can easily enable alerts from the recommended alerts, for instance. It's something what Microsoft is providing. If you don't know exactly what to look for, what to alert on for your cluster, they provide a couple of recommended alerts, still in preview as well. Just turn them on, say where you have to send that alert, and you're done for this piece. Because Azure Log Analytics is used behind the scenes, you have full access to the logs as well. So you can write your own KQL queries over here and then retrieve what you want from the actual logs. And there's a list of workbooks as well that you can then use. Now I enabled this on my cluster just to show you, because recently Azure Monitor for containers was changed a bit. So if you look closely, this is indeed an Azure Arc enabled cluster. This is the one on DigitalOcean. I enabled the latest version of Azure Monitor for containers on that DigitalOcean cluster, because DigitalOcean does not have this kind of nice view and monitoring. They just don't have that piece. And now, for example, there is some extra stuff like reports, for instance. They make it easier to not have to navigate to the workbooks, because there are actually workbooks behind it, to see things like, for example, I want to see the health of my deployments. You just click on that. And for example, I want to see the health of my deployment in not in all namespaces, but I want to see it, for example, in the namespace where I deployed my application via GitOps. Then I can just click on default, because it's in the default namespace. And I'll see my application, Redis and real-time and so on. I see, are they ready or not, up to date and available? And yes, they are, right? So this full view is enabled on any cluster out there in the field. You send it all to Log Analytics and you get this complete monitoring experience here inside the Azure environment. So it's really great feature to have that there in place. And then the last piece, of course, is Azure policy. I'm actually going to skip that because you know what this is about. Maybe a good thing to know is that the Kubernetes policies with Azure policy allow you a couple of things. And the first one, which is actually an interesting one, is enforcing GitOps. If you think about it, if you have like 10, maybe 100 of Kubernetes clusters out there in the field, you don't want to all manually configure them with GitOps. No, you want to just apply a policy to all these clusters and let them automatically install these GitOps pieces. That's possible with Azure policy to enforce it at scale. And then secondly, there are admission control policies. That's a little bit more special. I'll talk about it in a bit more detail later. But for example, GitOps configuration via policy, that's just this. You go to the Azure policy screen, you click on add new policy, you select the GitOps policy, and you fill out the parameters in the policy just the same as you would fill it out if you manually enable GitOps on your cluster. But as I said, this can be for 10, 50, 100 clusters or more at a time, depending on the scope of the policy, of course, where it is living. So very powerful. And yeah, the policy you saw earlier, the GitOps configuration you saw earlier, I actually deployed that one using policy. And in the beginning, you will see, of course, that the GitOps policy is not compliant on your cluster. You see that here, non-compliant. After a while, there is remediation taking place. the installation will be done, and then your policy will turn to 100% compliant. So it's basically recommended, if you're not in a testing environment, of course, to apply the GitOps configuration using a policy. It's much cleaner and clearer if you do it that way, and it's very easy to do. But don't forget to turn on remediation as well. So it's a policy that needs remediation turned on with a remediation task that it can fix what is not working, right? Now, of course, Azure policy with Kubernetes is a little bit more complicated than normal Azure policy, because policy on Kubernetes is just a bit more complicated. And maybe you've ever heard of something like Gatekeeper v3. What Azure policy is doing is basically saying, let's make it easy, and let's build upon Gatekeeper v3 to do policies to Kubernetes. That does have a bad side or an effect that might not be as good to you. That is that you can only use built-in policies. So Microsoft provides a list of policies using Azure policy that you can use with Gatekeeper, but then you have to let Microsoft do all the work. If you want to use custom Gatekeeper policies, you will have to install Gatekeeper yourself and do everything yourself manually. And for those who have done it, that can be a bit challenging. But Azure policy that's based on Gatekeeper v3 is luckily supported with virtually all flavors of Kubernetes and Azure. That means AKS itself, Azure Arc enabled Kubernetes, but also AKS engine, for instance. Now, what kind of policies are we talking about here? Well, for instance, a policy that looks like this, that do not allow privileged containers in Kubernetes cluster policy. I might not want that, to have privileged containers that have too many rights within my cluster. It's not safe to do so. Well, this policy can be configured, and I can configure it for auditing only, that I know what is happening. But I can also set the effect type to deny. And then this gatekeeper admission control system is kicking in effect, which means that if you do try on your cluster in real time, if you try to create a container that is privileged, this gatekeeper thing that Microsoft manages via Azure policy will actually say, no, you're not allowed to do that. It will be reflected in the events that indeed that didn't work. Now, as an example of policy for Kubernetes, I can show you the policies on my cluster here. Again, remember, this is a Kubernetes cluster running in DigitalOcean, but I installed the Azure policy and gatekeeper pieces on this as well. What you can see here, for example, in this screen, you can see gatekeeper audit, gatekeeper controller, and so on. These are things you have to install. The Microsoft documentation makes it clear that you have to install that before you start enabling these kind of policies. Now, I don't have a deny policy in here. I just have an example of a policy initiative that does all kinds of things. So, for example, it checks for privileged containers, approved host networking, and so forth. They have all been audited, and in this case, this cluster is compliant. Yeah. So again, nice to have this, that this Azure policy is extended to Kubernetes in Azure, but now also extended to any Kubernetes cluster out there in the field if you Arc enable it, of course. Yeah. Great. I think we've nearly come to the end of the presentation, or we are at the end of the presentation, I think. So we have seen two pieces, Azure Arc for servers and Azure Arc for Kubernetes. Just remember, servers part generally available, Kubernetes part still in public preview, and many things are still changing and improving in private preview that are still going on for Kubernetes. I expect somewhere in the coming months for that to be released, but of course, I cannot exactly tell you when that will be. But for now, the servers piece, of course, is something that fully is supported. Good. Now, are there any questions? If so, you can of course enable your mic and ask questions if you have them.
I would have one for me.
Okay, yeah.
First of all, hello here from Germany. Arno, thank you for the fantastic presentation. In the beginning, it's covered a little bit, but maybe you could touch on it one more time. I was wondering, when we do the connections Azure Arc, both with servers, or let's stick with the simple case of servers for now, like how the secret management is best handled then. So if I have a server that needs to connect to some other Azure resources, for example, how to best take care of that?
Yeah. So that's basically when you're talking about the that's not so fast, but when we are talking about the managed identity, right? That's the piece that you're referring to. So what you can do is the following thing. So wait a moment, it's slower than I thought. Yeah. So here, so you have an Azure Arc enabled server, and that one has on this endpoint over here, so on HTTP localhost on this port, you can basically do a request and say, hey, I'd like to have a token, for instance, to Key Vault, where your secrets are, right? What you, of course, then must do is make sure that the managed identity of your server has the necessary access rights to Key Vault to do a get on these secrets. And basically, that's all that is required. So if you're writing some code that can talk to this endpoint to obtain the token for Key Vault for your managed identity, you can retrieve from Key Vault the secret that you need to retrieve. That's basically how it works. How it will also work on a normal Azure VM in the cloud, although there the endpoint is a little bit different. But that's the only change here.
Fantastic. That clarifies. Thank you so much.
Okay, so I thank you all for your attendance. I will put the recording on the website of Micronos or Micronos, the one that you use to also register. Of course, if there are other questions, you can always reach out to me via social media. No problem there. Thank you for attending, and see you some other time. Bye bye.